work through some things, just kind of reviewing different strategies. So expanding and condensing. I know that really wasn't in this section, but it's still something we need to know. If things are multiplied, how do you break them up? Right, you add. So this is the natural log of x plus the natural log of, okay, a square root is like what power?
1/2.
So we could think of this as the natural log of x times y to the 1/2. So then what happens to that 1/2?
It goes to the front. So
Natural log of x plus 1/2 natural log of y. Okay. Is that one all right? So number 2. We have 2 things on top. So how many logs will I have on this one?
2. Well, 3.
2 on top and 1 on for the bottom. So 3 total. So we have log base 3 of u. What would the next one be?
2.
Plus 2 log base 3 of v. And then if it's on the bottom, we...
Minus or subtract.
Okay. Moving on. So example 3, if I ask you to condense that, that's 1 log. What do we do with the 2?
Exponent.
So that's a u squared. Since it was minus v, we divide by v. Are we remembering all of this so far? So this one, the 2 log base 2 of x, so that 2 would be a square. So we have log base 2 x squared plus log base 2 of 8, so we need to multiply by 8. I'm just going to write it as 8x squared, but you could put x squared times 8, that's fine. Minus, so that means,
Subtract.
so we'll have to
Or
divide. That 1/2 would turn into an exponent, so 2x plus 3, all to the 1/2 power. Are those okay?
See.
So let's practice all the different solving that we've done. So we've solved exponentials and logs in this section. With these exponentials, I told you that our strategy is always to isolate the exponential first. So what would I have to do on this one?
Divide by 2.
And then what do we do?
Add a log.
Can I go ahead and bring down my exponent when I do that? So to get x by itself,
Divide the log.
we need to divide by the 3 and the log. You can do them in separate steps, or we can just do it all at once. X equals. When you go to type this in, every time you push the log, it opens a parenthesis, so you have to close it. You also need a parenthesis around the entire denominator. And we know we can always check these just by plugging it back into the original. Did you get that one? Number 6. These were the longer ones. What do I do? When you do that, the x plus 1 comes down in front. Log of 2x out in front. So I have more than one x here. We need to first distribute that log. Now what do we need to do?
Divide the log 6 over. Or no, you could just subtract that.
Let's subtract over
Yeah.
this one, so we have the x's on the same side. You could bring them to the other. You just have to get everything with the x on one side. How does that help me?
Take out an x.
And then to get x by itself?
Divide the whole thing.
Mm-hmm. So, again, every time you push the log, it opens a parentheses, so you have to close that. You also need an extra set around the entire denominator because it has multiple terms.
So far, so good?
What would I do for problem number 7?
Natural law.
Mm-hmm. So when we have these, that's when we add natural log. I would start by combining these. When you do that, you add their exponents. So then you can add the natural log to each side. On the left, what happens when you have a natural log and an e?
Cancels.
Negative x plus 1. You cannot cancel the natural log and the e on the right because of the 3, so we just keep it. So then we can subtract the 1. And divide everything by negative 1.
How do you do that?
So you type in the ln 3, and then depending, there's a couple different e's on the calculator. If you do second, the natural log, it brings up e, but it makes you put in an exponent. Just put a 1. Or there's another e above the division sign where you don't have to put in an exponent.
You have to put a parentheses around the whole thing.
Yes, so we need to set here. Anybody need help getting that one to work? One of these. What would I have to do in this problem?
Subtract.
And then,
Divide those by.
okay. Now what?
Add logs.
Okay. So the exponent comes down.
Distribute the log.
You can either distribute it, or since it's their only x, we could divide it over first. So, might be faster to divide it, but both will work. Then what would we do?
Add the 2 and divide by 2.
Mm-hmm. So we got a nice answer this time, didn't we? Does anyone see?
I got 1.666666667.
If you caught that, 6 is 1.2. So we have a common base. You can set the exponents equal. So 3x equals 3 and
I
x
seen
equals
that,
1.
I just didn't want to say
But,
that.
see, you just forgot no skip practice the other way.
Wait,
But
what? Say it again.
we had a common base here. 6 is 1.2. And if they have the same base, you can just set the exponents equal. You don't have to add logs. But we can. We added the logs and we got the same answer. It works. Let's practice a few log problems and then I'm done. So what would I do on example 9? Really 2 options.
Add the 2 as well.
Yep, we can either take the 2 up to an exponent or we can divide by 2. Does it matter which one we do? No. Which one you want me to do? Alright. So you'll get the same answer either way. Then, if you only have a log on one side, we change it to exponential. So it'd be 9 to the 1/2 power equals 2x minus 1. What is 9 to the 1/2?
I think it's 2 minus x.
Oh, thank you.
I was doing some kind of after that, it'd be somewhere.
Alright, so 9 to the 1/2, that just means the square root of 9, which is 3. So we can subtract over our 2, divide by -1, and x is -1. Always check that if you put it back in, your argument is positive. 2 minus -1 is 3, so we're okay.
I remember that we took
Good stuff.
7th grade.
Alright, what about the next one?
Foil.
Yeah.
Stop telling the answers wrong.
So, if these logs are added, we combine them by multiplying. So we have to take x plus 2 times x minus 2. X squared minus 4. Then, there's a log on one side, so we use the definition and change it to exponential. So 5 to the first equals x squared minus 4. 5 to the first is just 5. Add over our 4 and we get 9. How do we get rid of a square?
Screw it.
And with that, plus and minus.
Plus or minus 3.
Alright, are both answers okay?
Nope.
The negative.
Just trace.
So our answer is 3. Okay, the last two, everything has a log. So our strategy was if we can get one log on each side, we can drop it. So on problem 11, these logs are subtracted, so when I put them together, we divide. Now we have one log on each side, so we can drop those logs. Have to get rid of the fraction, so we multiply by 3 plus x on each side. Subtract over my 3x. And subtract over my 5. And get x equals 4. Is that answer okay? And number 12. If these logs are subtracted, how do we put them together?
Divide.
Mm-hmm. Okay, now you have to be careful with the one on the other side. There's a negative out in front, so what does that do? It's like a -1 exponent. A -1 exponent just flips it. So now we can drop the logs. We have to cross multiply. 4x squared minus 8x minus 2x plus 4 equals 4. If I subtract that 4 over, those cancel. So how would I solve this?
Take an x.
If I pulled out that x, we get 4x, oops, not squared anymore, just 4x minus 10. So we set those equal to 0. And we get 0 and 5/2. Are both of those options?
0.
0 is not, so 5/2 is the only answer.